Welcome back to the deep dive. Today, we are going to do something that, well, it might feel a little destabilizing. We're going to look at the literal ground beneath our feet, the rocks, the hills, the cliffs you drive past, and ask a very specific question. Are we reading the story right?
It's a huge question.
Yeah.
And it challenges one of the most fundamental things we learn, in school. You see a layer of rock, you think time. You see a canyon, you think millions of years.
Exactly. It's the standard tape recorder view of Earth's history. The assumption is that the geologic record is, well, it's a history book.
A book you can just read.
But the research we're looking at today suggests that this record might not be a history book at all. It might be more like a crime scene.
And that's a key distinction. Because if you're looking for a slow, gradual history in a crime scene, you're going to miss the evidence of the actual event.
Right. So we are diving into the work of Dr. Tasman Walker. He's a fascinating figure.
Oh, he really is. He bridges two worlds.
Yes.
He's a mechanical engineer who worked in the coal industry, but then he went back to get a PhD in earth sciences.
So he looks at rocks, but he thinks like an engineer. He's looking for mechanics, for fluid flow.
Structural integrity, yeah. And his mission in these sources is to dismantle what he calls the philosophical handcuffs of modern geology. He's basically stepping into the ring for the heavyweight title fight of earth science.
Uniformitarianism versus catastrophism.
That's the one.
That sounds intense. Okay, so let's define those terms for everyone.
Sure. So uniformitarianism is the reigning champion. It's the idea that the present is the key to the past. The slow processes we see today, a river silting up, a little bit of wind erosion, those are the only tools you're allowed to use to explain the past.
So if a canyon is deep, it just must have taken millions of years to carve.
That's the logic. Versus catastrophism, which is the challenger. It says, no, the features we see weren't formed by a slow trickle of time. They were formed by a singular, violent, global event.
And in Walker's case, he's arguing specifically for the biblical flood model. But, and this is important, he's doing it with data on fluid dynamics and sedimentation.
Exactly. Not from a pulpit.
Right. And the goal of this deep dive isn't to tell you what to believe, but just to show you how the physical evidence, the diamonds, the dinosaur bones, it all looks completely different depending on which pair of glasses you're wearing.
And Walker uses this great metaphor to explain why we wear the old Earth glasses in the first place. He calls it the three-cord rope.
I love this analogy. It really breaks down the logic. Let's unpack that rope.
Okay, so this goes back to the 1830s. A guy named Charles Lyell. He wrote Principles of Geology.
He's basically the godfather of the millions of years timeline.
He is. But Walker points out that Lyell had a very clear agenda. In his private letters, Lyell actually wrote that he wanted to free the science from Moses.
Wow. So he wasn't just observing rocks. He was actively trying to delete the biblical timeline.
Right. So he braided this three-cord rope to strangle the catastrophe model. Cord number 1, dismiss the biblical history as just myth.
Okay.
Cord number 2, interpret every single rock layer through slow, gradual processes. And cord number 3, insist that these geological features demand long periods of time.
The argument being, look at this massive cliff. It must have taken forever to form.
That's it. And Walker's whole argument in these papers is that if you untwist those cords, if you actually test those assumptions, the whole rope just snaps. The timeline falls apart.
Okay, so let's pull on that first cord.
Yeah.
The idea that geology needs deep time. This is where the aha moments really started for me, especially with the fossils.
It's the most common objection, right? Fossils take forever to form. But biologically, that makes no sense at all.
Right. I mean, just think about it. If you have a goldfish and it dies,
And you just leave it in the bowl.
it doesn't turn into a beautiful fossil after 1,000 years. It floats, it gets slimy, it falls apart.
Or the other fish eat it. It's gone in, what, a week?
Exactly. Walker points out that to get a fossil, you need rapid burial. You have to seal it off from oxygen and scavengers instantly.
And when we look at the fossil record, we don't really see slow and steady.
You see panic.
The sources mention the dinosaur graveyard in Utah, the Dinosaur National Monument. A classic example. You have hundreds of dinosaur bones just jumbled together in this massive logjam of sediment. The sign at the visitor center says they died in a drought and the bones were washed into a river. But Walker argues the sheer volume of mud and the chaotic mixing. It points to a catastrophic debris flow, a wall of mud.
And then there's the posture. I've seen this in museums, the dinosaur skeleton with its head thrown way back over its spine.
The opistotonic posture.
Yeah.
For a long time, paleontologists just thought it was, a death pose.
Yeah.
But modern veterinary science tells us that posture is caused by severe muscle spasms from hypoxia,
Hypoxia. Lack of oxygen.
suffocation, asphyxiation. These animals were drowning or suffocating in wet mud.
That is a grim picture. It's not a dinosaur laying down for a nap.
No, it's a dinosaur gasping for air as it gets buried alive. There's this startling example from Inner Mongolia in the research. A herd of over 25 dinosaurs found in the same sediment layer, all facing the same direction.
Like they were stuck in quicksand.
Exactly. Their back legs were plunged deep in the mud, but their upper bodies were twisted, like they were running from something, hit a sediment trap, and were buried while struggling to escape.
That is not slow accumulation. That's an instant.
An instant in time.
Okay, so biological things need to be buried fast. That makes sense. But what about the rocks themselves? The layers. I was always taught that the stripes in the Grand Canyon are basically a calendar. One layer, 1 year.
The Varv theory. And it sounds reasonable until you look at what happened at Mount St. Helens.
The volcano in Washington.
1980, we all know it exploded. But for geologists, it was a real-time lab. In a single afternoon, a deposit of stratified sediment, 8 meters thick, was laid down.
8 meters.
Yeah,
An afternoon.
Yes, and it was perfectly layered, fine laminae. If you walked up to that deposit today, without knowing about the volcano, you'd say, look, thousands of layers. This must be 10,000 years of deposits.
But it was just a few hours of violent flow.
Exactly. Walker cites experiments by Guy Berthold who showed that moving water sorts particles into layers automatically. You don't need time to make layers. You need a current.
That really undermines the whole calendar idea. But surely hard stuff takes time. I mean, diamonds.
A diamond is forever. Yeah, that's great marketing, but it's bad science. Walker points to the synthetic diamond industry. Companies like LifeGem or Genesis. They can take carbon. They can actually take the ashes of your pet and turn it into a certified gem-quality diamond.
How long does that take?
Weeks, sometimes days. It's not about time, it's about the right conditions, the pressure and the heat.
And the opals. This was my favorite story in the stack. The guy in the shed.
Len Cram, he's an Australian legend out in Lightning Ridge. He challenged the idea that opals need millions of years. He literally grows them in glass jars in his shed.
He's not superheating them or anything.
No, it's a chemical process. He uses local dirt and a liquid electrolyte soup, and he grows high-quality opals in a matter of weeks. The point Walker is making is we've been conditioned to think hard rock equals old rock. But the chemistry says hard rock equals right conditions.
So if we pull on cord number 1, it unravels. You don't need millions of years for fossils, layers, or gems. But that leads to cord number 2, the assumption that slow processes are the only explanation.
Right. And Walker argues that not only are slow processes not the only explanation, they actually fail to explain the big geological features. They just don't work.
Okay, let's talk about coal, the swamp model from school, right? Trees die, sink, build up, and eventually coal.
That's the story. But if you actually look at a coal seam, the physical evidence screams transport, not growth.
How so?
Well, first was the soil.
Yeah.
If these were forests growing for thousands of years, there should be a thick layer of root soil under the coal. But usually, the coal sits directly on rock. Granite, shale, a sharp contact line. No soil.
So the plants didn't grow there. They were dumped there.
Exactly. And then you find marine fossils in the coal. Tiny marine tube worms called Spirorbis. Why would ocean creatures be in a freshwater swamp?
Unless the ocean washed the whole forest away.
Precisely. And then, the smoking gun. Polystrate fossils.
Polymany. Straight layers.
Right. These are tree trunks standing vertically, cutting through multiple layers of rock. A tree can start in a coal seam, go up through sandstone, and end in a layer of shale.
So, okay, if the sandstone took 1 million years to accumulate around the tree
would have rotted away 999,000 years ago. You can't have a tree standing there for eons while sediment slowly builds up. It implies the sediment arrived all at once.
or at least in a very short burst.
Right. Even Derek Ager, who was a famous evolutionary geologist and very anti-creationist, he admitted this. He said we can't escape the conclusion that sedimentation was, at times, very rapid. He basically admitted the slow and steady rule breaks down.
So we've got rapid burial, rapid rock formation, rapid sedimentation. But what about the scale? I mean, a local flood is one thing, but a global flood.
This is where Walker talks about pancakes,
Pancakes.
an analogy for sedimentary blankets. A river delta, today, creates a localized fan shape. But in the geologic record, we see layers that cover entire continents.
Like the White Cliffs of Dover.
Right, that famous chalk layer. It's not just in England. You can trace that same bed under the English Channel, into France, through Germany, Poland, all the way down to Turkey and Egypt.
That is a massive, massive sheet of chalk.
It's a pancake that spans continents. And Walker asks, what modern process does that? A river can't do it. A local flood can't do it. It implies a global mechanism.
And what about the gaps between the layers, the paraconformities?
The flat gaps, yes.
Yeah.
This is a subtle point, but it's devastating for the deep timeline. So you have layer A, and according to the timeline, it's 250 million years old. And layer B, sitting right on top, is 50 million years old.
So there's 200 million years missing.
Right. The theory says for those 200 million years, the land was exposed, but nothing was deposited. But if rock sits exposed for that long, what should happen to it?
It should erode. It should have canyons, valleys, gullies. It should be a mess.
Exactly. But when you look at that contact line, like in the Grand Canyon, it's often perfectly flat, like a knife edge.
So the erosion never happened.
Which suggests the time never happened. Walker argues layer B was just deposited almost immediately after layer A. The millions of years are just an assumption inserted into a gap with no physical evidence.
Okay, so we've pulled apart the need for time and the slow process explanation. That leaves us with the alternative. Chord number 3, the flood model itself.
Right, and this is important. Walker isn't just saying geology is wrong. He's proposing a specific mechanism, catastrophic plate tectonics.
The continental sprint idea.
It is. We're taught continents drift at the speed your fingernails grow, inches per year. The physics suggests that during this event, the plates were moving miles per hour.
Miles per hour? That's unimaginable. Is there any evidence for that kind of speed?
There is, and it's deep in the earth. Seismologists have imaged what they call cold slabs, massive chunks of ocean crust that have subducted, dive down right.
Exactly, dive down into the mantle. Now, the mantle is incredibly hot, so if those slabs went down slowly,
they would have melted.
They'd have reached thermal equilibrium, but they're still cold, which suggests they plunged down there very recently and very rapidly. They haven't had time to heat up yet.
That connects to the magnetic reversals too, doesn't it?
It does. We know Earth's magnetic field flips north-south. In lava flows in the Pacific Northwest, they found evidence that the magnetic field was flipping while the lava was cooling.
But lava cools in weeks.
Exactly. So the Earth's magnetic field was flipping in days, not thousands of years. It indicates the core was in chaotic flux.
So if the plates are sprinting and the mantle is churning, what's the water doing?
Walker breaks it into 2 main stages. Phase 1 is the inundatory stage. Water surges over the land. This is the rising water that lays down those massive sedimentary pancakes and buries the dinosaurs.
And then the water has to go somewhere. Phase 2, the recessive stage. Walker calls this the Erodozoic phase because it carved the landscape we see today. The continents lift up, the new ocean basins sink, and the water rushes off the land.
And this explains the overfit valleys.
Right. You've driven through these. You see a valley that's 2 miles wide, massive cliffs, and in the middle, there's this tiny little creek.
And you think, wow, that little creek was busy.
Walker says no, the creek didn't do it. A massive sheet of receding floodwater carved the valley quickly, like a water jet. And the creek is just what's left.
It also explains water gaps, rivers that cut straight through a mountain range.
Exactly. If the mountains were there first, the river would go around. But if the water was flowing over the mountains as they were rising, it slices right through.
It really is a completely different lens. You're not looking at slow erosion, you're looking at the scars of a violent event. But there's one final piece, the Ice Age.
This is the synthesis. People ask, does the Bible mention the Ice Age? Walker argues that the Ice Age is a direct consequence of the flood.
How? I thought ice ages happen because of slow orbital wobbles.
The Milankovitch cycles. But the problem is the Goldilocks paradox. To get an ice age, you need 2 things that don't usually go together. Cold summers, so snow doesn't melt, but also massive evaporation to create the snow.
And evaporation requires heat. Cold air is dry air.
Right. If you just turn down the sun, you get a cold, dry desert, not an ice sheet. The flood fixes the paradox. Think back to all that underwater volcanism and friction. It heats the oceans.
Hot oceans mean massive evaporation.
Step 1, moisture. Check.
Step 2.
Cold summers, all that volcanic activity spewed billions of tons of ash into the stratosphere, blocking the sun.
So you have a hot, steaming ocean pumping moisture onto a continent that's shaded and freezing.
It's a snow machine. It would dump massive amounts of ice on the northern continents for centuries. Then, as the oceans cooled and the ash settled, the machine turned off and the ice melted.
And this explains the woolly mammoths in Siberia.
It's the only model that really does. Siberia today is a frozen wasteland. It can't support huge herds of elephants. But if the Arctic Ocean was warm,
The coast of Siberia would have been temperate and lush.
exactly, the mammoths thrived there. Then, as the oceans cooled, the climate snapped, and they were frozen in place.
It's fascinating how it all ties together. The fossils, the layers, the tectonics, the climate.
That's Walker's ultimate point. He believes the biblical flood model isn't just a story. It's a scientific framework that actually explains the anomalies, the rapid fossils, the global layers that the standard model has to make excuses for.
So it brings us back to that three-chord rope. Walker is saying the rope is broken, the rocks don't need time, slow processes can't explain the geology, and the catastrophic model actually works.
And the implications of that are massive. Because the geologic record is the foundation for evolution. Evolution needs deep time. It relies on those billions of years.
Time is the hero of the plot.
It is. Given enough time, the impossible becomes possible. But if Walker's right, if the geologic column isn't a timeline, but a snapshot of one chaotic year,
Then the time for evolution just vanishes.
it's the Achilles heel. Without deep time, the biological theory collapses. There's just no room for it to happen.
That is a huge thought to leave us with. I mean, it changes how you see the world. Next time you're driving past a road cut or hiking in a canyon, take a second look.
Ask yourself, am I looking at millions of years of quiet history, or am I looking at the wreckage of a single world-altering catastrophe?
It definitely changes the view. Thanks for taking the plunge with us on this deep dive.
See you next time.